So, hello everyone. Welcome to day 61 of Learning Data Science. And yes, in the previous past 2 weeks, you would have noticed that, yeah, I wasn't making videos in this, right? And basically, for what? Because certainly we were doing several things, right? We were working on Dhara project, right? Simultaneously, what we were doing, if you could look into the channel, I have made one more playlist in which we were applying for the jobs as well, right? And how we are applying that, we have also made that as well, right? So in the previous past 2 weeks, I've been into this. Now what I will do, means like at the most, Dhara is completed. Only the integration part is left. And about the jobs and the thing, right? We are basically guiding day by day, right? And we are just trying to show you how we can apply for the several jobs and we can hit the companies, right? So we will be discussing that. And further in the following weeks or from the day ahead from today, what we are going to do, basically we are trying to handle all these things, all these three things. It's not that I will solely work on the Dhara or I will solely work on applying for projects, right? Or sorry, applying for jobs, or I will just skip those. No, what I will do, I will just parallelly go on with this thing simultaneously, one by one. Okay. And in a day, we'll try to cover all these things, right? So now, uh, let's recall whatever thing we have been discussed so far. Okay. So basically, this particular video is for us to recall whatever things we have learned so far and till now, where are we, right? So pardon me for my bad camera quality because yeah, that's the thing issue. So we will just move ahead with the things, okay? And what I will do, I will simply share my whiteboard at once, okay? I will just try opening the whiteboard if it's okay. Just give me a second. The share the book attendance document. Yeah. So we'll discuss all those things, right? It's just opening in a minute. So basically, if you could remember this, okay, so basically this particular thing, I think I have shared the wrong whiteboard. So, okay, if you could remember what all things we have discussed in EDA, right? What all things we have done till now, and basically what comes under EDA, exploratory data analysis, right? What comes under, right? We discussed about four business decision, right? If you could remember, the first moment of business decision, second moment of business decision, third, and similarly fourth. Okay. So if you could remember, I want you to just write it on the chat box. What all things you could remember of that, right? So I will discuss one by one. So first moment of business decision, what it comes, obviously, the first moment of the business decision is the mean, median, and mode. Okay. Whenever someone tells about mean, he discusses about median, he discusses about mode. So it's the first moment of business decision, and we often call it as measures of central tendency. In the stats chapter in mathematics, you could recall of that. What is the meaning of measures of central tendency, right? So if we discussed about mean, so what is the mean? Mean is the average of all the data points. What is the median? Median is the middlemost value. What is the mode? The highest number of data points present in the particular data set, right? So this happens with the first moment of business decision, right? And also we discussed about how we can write about that particular means like, for example, okay, let's see. Okay. What I will do, I will just open a new, what you can say, a new whiteboard. Okay, so I'll discuss all those things. Okay, a new whiteboard, and we have already discussed about the things what is mean. Now, we will move on to the second moment of business this season. But before that, the mean. Okay, mean. How do we find the mean? So in the coding also we have discussed that, for example, PD is our sorry, DF is our data frame. So within our data frame, for example, the column name is X. Okay, we will write this like this. The column name is X, and within that, what we are going to do, we are going to find the mean. Okay, so similarly, we write this if we want the median as well. So similarly, we write like this median, and similarly for the mode as well, we write here mode. Okay, so this was pertaining to first moment of business decision, right? What is the second moment of business decision, right? What do you mean by second moment of business decision? So second moment of business decision means measures of dispersion. If you could recall again, what is the measures of dispersion? Dispersion by the name itself. Dispersion by the name itself, you can recall that how our data points is dispersed from mean. Okay. For example, this is X and Y axis. For example, for say this is our mean, this data point is our mean. Okay. Let me choose another color for that as well so that you can easily understand it. Okay. For example, this is our mean. Okay. This is our mean, and these are all the several data points here. You can, these are all the data points, these data points. This is the data point, this is the data point, this is the data point, this is the data point. So you can recall what is the dispersion of it, how my data points are deviated from mean. Okay. How our data point is deviated and how it is calculated. It is calculated obviously the measures of dispersion, if you could recall of that. Okay, we have discussed about the first is the standard deviation. Okay, standard deviation we denote it by sigma, and second one is variance, we denote it by sigma square. Okay, we discussed these things with sigma square. And third is the range range. And what is range? It is the maximum and minimum value, maximum minus minimum value. Okay. And we have also discussed about the standard deviation. What is the formula for standard deviation? So if you could recall what I told that how our data point is deviated from the mean. Okay. So the value of standard deviation, it would be, you can tell it's as x minus mu divided by n. N is the number of data points, and we would take the sigma of it. Okay, sigma. It is x minus mu under root this n. Okay, and what is the variance? What is variance? Variance is the sigma square. If we will square this value, okay, if we will square these values, then this is called variance. This is called variance. Okay, so these all things we discussed, and also like just give me a second. I am sharing the whiteboard again at once. I'm just looking for the whiteboard which I have been used in just discussing the videos. Okay, so I'm using that as well. Okay, so this is the covariance and these all things, the median, the box plot. Yeah, these all things are there. Okay, so let's not move. Yeah, you can see here, you can see here the formula for standard deviation, which I've written x minus mu by n sigma. And I am taking here under root and I'm also doing here square. So similarly, this 2 and this thing will get cancelled, and ultimately what will the result? It will be sigma. So sorry, it will be summation of x minus sigma, x minus mu divided by n. Okay, and similarly for standard deviation is the same. And we have also discussed about, if you could remember, third moment of business decision. The third moment of business decision is skewness. Okay, and again, what do you understand by skewness? So what is skewness? Okay, I want you to comment it on the comment section. What do you mean by skewness? Okay, so particularly skewness, what it does, it just helps us to show the distribution of the data points. What is skewness? It shows the distribution of our data points, how our data points is distributed. Okay, and again, with the help of that distribution, we are able to find out that whether there is outliers in our data set or not. I will just look into that tab as well, but I've explained that all these things. If it's not there, if I will not found it, what I will do, I will just simply, in short, I will explain. Yeah, I have found that. Meanwhile, it's opening. Yeah, you can see here skewness. Skewness means what? The distribution of our data points. You can see here the skewed, the one which I have circled here. You can see here the little bit skewness is there, and this is called right skewed, and this is called left skewed. S value will be greater than 0, sorry, less than 0, which is also called as negative skewness. And it is also called as positive skewness. And one thing you have to remember in the calculating the skewness, whenever our skewness value will be equal to 0, what it means? It means the our graph or our the data points is uh, properly distributed, or you can say normally distribution, di distributed, normal distribution. You will get a curve of a bell shape. Okay, you will get a curve. I'm not able to use my pen here. Why I'm not able to use that? Yeah, so you can see here, this is our data point and our graph will look like this. So you can see here it is cutting into two equal halves. So it will be a normally distribution. Okay. And also one thing which I've told you to keep it in mind in normal distribution is that mean is equal to median is equal to mode. Okay. So my mean is equal to, uh, I will just write here mean. My mean is equal to median is equal to median is equal to mode. And what, and when it will be in my value s is equal to 0, which is in normal distribution. And whenever my s is less than 0, s is less than 0, so what will happen? The sign will change like this. And if my s is greater than 0, then the sign will change like this. Okay, mean will be the greater, median will be the less greater than mean, and mode will be the smallest in my positive skewness. And again, we have also learned about in fourth moment of business decision, we learned about kurtosis. Okay, so kurtosis, it also tells about the distribution, and how we can look again upon the kurtosis is that by the peak. If there is a certain peak, you can tell that the outliers is present. And when it is a certain peak, when it comes when my kurtosis value will be greater than 3. Here it's not 0, it's 3. My kurtosis value will be greater than 3. And again, if it's greater than 3, then it will follow the same rule. Median is equal to median greater than mean greater than median greater than mode. Whenever there is a positive kurtosis. Okay. And whenever there is a negative kurtosis, you can see a graph like this, a flat bend mountain shape, this shape. Again, this is a negative kurtosis and its value will be obviously less than 3, less than 3, we call it. Okay. And if it's normal distribution, then obviously it will be a bell-shaped curve. Okay. Pardon me, this is not a normal distribution. You can see a skewness here, modern like this. Here, you will get it. Okay. Normal distribution. Okay. And I've also renamed some of the things. If you could remember that whenever there is a normal kurtosis, what do we call? We call is that meso mesokurtosis. The name for the normal kurtosis, it is also known as mesokurtosis. And for the negative, sorry, for the negative one, what we call is a plateau kurtosis. Plateau curves. So these all things we discussed in fourth moment of business decision. And again, we came upon the fifth moment of business decision. Basically, the fifth moment of business decision, you can call it the graphs. We discussed about the univariate graphs, the bivariate graphs. Again, what is a univariate graph? If you could recall, if you can, then just type it in the comment section. What do you mean by univariate graphs? So the univariate graphs, it supply only one feature whenever we are plotting any graph for the one column or one feature, then we generally do that with univariate graph by the name itself. And what all graphs comes under univariate? If you could recall, the box plot is there again. And again, whenever you are reading some of the graphs, you should be able to recall its primary purpose and secondary purpose as well. So we learned about histogram is a univariate plot. What is the primary purpose of histogram? The primary purpose, you can tell, it's just help us to find the shape of the distribution. Okay. What's the secondary purpose? Secondary purpose is finding the outliers, right? Similarly, bar graph is there. The box plot is there. Box plot again, what is used for? The primary purpose, you can recall, it's for finding the outliers. And what is the secondary for box plot? The shape of the distribution. Okay. Again, QQ plot is there. QQ plot, how we define it. Again, we have to see that if our data points lies 50% of our data points lies on a straight line or not. So this is basically the QQ plot. We discussed about the bivariate plot, the scatter plot. Again, what is the primary purpose of scatter plot? To find the strength, to find the direction. One is strength, one is direction. And the third thing, what is the third thing? I want you to comment it in the comment section. What is the third thing? I have missed it. Right? So the primary purpose of the scatter plot, you have to write it. And again, what is the secondary purpose of that? Finding the outliers as well in the scatter plot. And again, how we are going to find the strength? Okay. Strength is find out again with the covariance and correlation. Again, what is the formula for correlation? What is the formula for covariance? Okay. What is the formula for correlation and what is the formula for covariance? And also we discussed about the mod R. Okay, we discussed all things, and the value of arch, if it's less than 0.45, then it's a weak, the strength is weak. If it's greater than 0.85, then it's strong. If it's in the middle, then it's average. Okay, so this is the correlation coefficient. And how do we find the covariance? Covariance is the simply, we find out covariance is the uh, sorry, correlation we find with the help of covariance of x comma y divided by standard deviation of x comma standard deviation of y. Okay, if I would find that the whiteboard as well, so I'll be just explaining you so that it will be helpful. I've opened it just now. Yeah, you can see here the R value covariance of x comma y by the standard deviation of x and y. Okay, the bivariate feature you can see here. Uh, Scattered plot, primary purpose it use the check the data is linear or not, strong, and also direction. So the first thing is checking the linearity, second thing is the strength, and third is the direction. Okay, and the secondary purpose again it's the cluster. I have discussed the mod value R, you can see here, weak, moderate, strong. This is the covariance formula, and the correlation standardizes covariance to a range of -1 to 1, making it easier to represent. Okay, so we are taking the mod value in the correlation, and we are using the standard scaling for that. You can see here the Z score. First, we do the scaling part, the standardization, and when we are getting our the stand scale free data, so what we are going to do, we are then converting our covariance into correlation. Okay, and there is a major difference between covariance and correlation is that one will only show the strength and one will show the strength plus direction. Okay, so I want you to differentiate between these two, which shows only strength and which shows both the strength and direction, covariance or correlation. Okay, and moving ahead, what all things we discussed, that we have found the outliers, then we discussed about the outliers treatment. We discussed about the 3 R's technique. The first outlier treatment, it's 3 R technique. And what is those 3 R stands for? Certainly, first one is retain. Uh, it's not in a serial order. You can remember as much as you means like the way which you can. Okay, retain is there, rectify is there. Okay, so these all things is there. And the second method of treating the outliers, we discussed about the winsorization. Okay, again, what is winsorization? In winsorization, what we do basically, uh, in winsorization, in short, what we do, uh, if our outliers is in the left, so what we will do, the 5% of data, the data is from 100%, right? 0 to 100% is there. The starting 5%, 0 to 5%, what we will do for that particular data, we will do the average for that data points. We will do the average for that. Average of all the data points, we will keep that under 0 to 5%. And if my data is in the right, sorry, my outliers in the right, so what we'll do from 95 to 100% at 5% of data will be there. We will replace those data points with the average of the values. So in winsorization, we have done these things. Again, we have discussed about in winsorization, there are several techniques. The Gaussian method is there, right? The quantile method is there, right? We discussed all these things. We also discussed about the trimming, the third method of outliers treatment. What do you mean by trimming? Trimming simply what we are going to do. we are removing, we are just trimming the data set, the 5% of data which is in initialization, we were averaging those values. Now what we will be doing, we will simply remove that value. So trimming is there, right? And another thing we discussed about what was the encoding part. If we have to convert our numerical data into categorical data, so what we'll be doing, again, we'll be creating dummy variables. We will be encoding uh, the creation of dummy variables. I've told about one hot encoding is there, right? And again, discretization is there. Discretization is for categorical data to numerical data. And numerical data to categorical data, what we are doing, we are creating the dummy variables. We are using one hot encoding there. Okay, I'll just open the whiteboard as well. Yeah, so you can see here the dummy variable pre-creation forever. If you want to change our data, you can see here label encoding is there, ordinal encoding, one hot encoding, binary encoding. These all things is there. This is our categorical data. This the categorical data. If you want to convert into numerical data, so we are using that. And if you are having the numerical data and we want to convert into categorical data, so for that we are using discretization. And in discretization, we have learned about binarization was there, right? We discussed about how we can convert into two or more categories, right? Yeah, you can see here discretization. This is numerical data. We are converting into categorical data. Here we are doing binarization. Why? Because low, medium, high is there. Rounding of the values. Rounding the values means if it's less than 3.5, then you will consider that 4. If it's less than, if it's greater than 5 or 5, then it will be the floor value and the seal value. And binning is there, adaptive binning, fixed with binning. What do you mean by adaptive binning? You can see here, we can set the bins according to our needs. For example, 2, 3, 4, 5, etc. Then we will divide it into number of data points. Binning means we are categorizing this. For example, we are taking from 2 to 3, and bins were not in continuous form. The bins will be not in the continuous form, and we will take upon our choice. Two bins will be there or three bins will be there, right? For example, 100 data points is there, and we have to divide into two bins. So it will happen? It will convert from 0 to 50 and from 50 to 100. Similarly with that, if 3, then 100 divided by 3. If 4, 100 divided by 4. So 25 sets of each bin will be there. That is adaptive binning. And in the fixed with binning, you can see here, we are assigning values by the set of bins according to our convenience. Like low than, in the continuous form is there. Here you can see if you are dividing any number, if you will divide it, if you will convert into bins, so it will not be in the, what you can say, the continuous form. But here you can see here, the age is greater than 12 and less than 18. If you will plot the histogram for that as well, you can similarly understand that these data is in continuous form. So this happens to be rounding, binning. We discussed all these things, the discretization. And tomorrow, what will we going to do? We will be going to discuss about the transformation. Don't get confused with the transformers we use in AI. It's totally different, the transformers and transformation. Here, we will be doing transformation. And why we will be doing that? We will be discussing again in the same video tomorrow at the same time. Okay. Till then, you just keep revising it, keep practicing 100 lines of code every day. See you tomorrow. Till then, goodbye. Take care.